Hey guys, welcome back to the channel. So today we are going to be talking about self-shielded flux core. So let's go over the safety equipment, some of the tools that I'll be using, and how to set this thing up. So safety equipment is pretty standard. I got my leather coat here, my welding gloves, safety glasses, my weld helmet, and a couple sets of pliers. I always like keeping some pliers around just because they are very useful for when you're grabbing hot metal. Also make sure that you keep your arms and legs covered and that you have appropriate footwear. I also want to talk about some of the other tools that I will be using. I've got my wire brush here. I've got my chipping hammer here. This is a flux process, so you will have slag that you will need to chip off, so make sure you got your chipping hammer and a wire brush. I've also picked up this nozzle gel stuff just to help keep things a little bit clean, and I also have this spring-loaded punch with me, so the more I push on it, it loads up. Yeah. Goes ka-ting and leaves a mark that you can't really quite see. But anyway, I use this when some of the slag gets stuck in a hard to get to position, and I can just kind of work my way in there, pound it, and it usually breaks it apart. If it doesn't break it apart, then I know that I'm just going to be having a rough day. So that's my safety equipment and the tools that I'm going to be using. Let's talk about how to set up the machine. So here's your standard MIG welding gun. As you can see, this is just a normal MIG gun. The first thing that you want to do, since this is a self-shielding process, that means that it has no gas shielding. Doesn't even use gas. So the first thing you want to do, take that off, okay? So this is your gas diffuser, and you can see mine is kind of already beat up. This is all from the flux core process when I was trying to get everything working. And yeah, just go ahead and take that off. Set that over there. So now you've got this. Now, parts that you need to know. This here, this first copper piece, this is your contact tip. The amount of wire that's sticking out from the contact tip is called your stick out. So keep that in mind. If any of you guys have welded solid wire MIG, the solid wire is the stuff that's got the copper on it, and you need a shielding gas. Most of the time you need a slightly longer stick out or amount of wire that's coming out from the contact tip than you would normally use for solid wire. So keep that in mind. So that's the first thing that you're going to do is go ahead and pull off that gas diffuser. There are torches that are made that don't have, you can kind of see the holes here. This gun is set up to run with gas, so these holes are where the gas comes out. They do make guns out there that don't have any gas holes that are specifically made for flux core welding only. And when I say flux core, in this context, I mean self-shielding wire. There's two different types of flux cores out there, and it really helps if you get specific about which one. There's the self-shielding, which is this kind, that requires no shielding gas, and there's also a dual shield flux core out there. The dual shield requires a CO2 shielding gas, so that's carbon dioxide shielding gas, 100%. So make sure you make the distinction which flux core you have. Now, let me grab the camera here, set this down. Let's talk about what's going on in here. Open this up. So this is my feed setup. Couple of things that you need to remember. Now, depending on what machine you have, oh, and you can't see it. Okay, let me pull the camera off the tripod here. There we go. All right. See up there? I've got two terminals. One's marked a positive and one is marked a negative. Depending on what your machine is, you might have the same kind of terminals in there. If you are doing self-shielding flux core, gasless flux core, you need to make sure that these are the terminals for the polarity of your MIG gun. The polarity of your MIG gun needs to be set to the negative, or DC electrode negative. So that also means that your ground clamp, come here, your ground clamp needs to be on the positive. See if I can get that to focus a little bit. Not really, it looks like, there we go. So, ground clamp to the positive, your gun to the negative. If you are welding solid wire, so that's the copper coated one, or dual shield flux core, then your polarity is the reverse of this. So your gun will be set to the positive and your ground would be set over to the negative. But as this is the self-shielding process, that is your polarity setup. You want DC electrode negative. Now, another thing that I've got on here, and I need to grab a light so that you can see it. Come here. Okay. So, there's my drive rollers. And then, oh yeah, that's right, this thing's magnetic. Woohoo. Come on. No, there. Okay, so, got my drive rollers here. And this is my wire lead-in. And you'll notice I have this little felt thing that's hooked on there. So this here is a wire lubricator and cleaner. I would recommend getting one. I found out pretty quickly that this particular wire is just dirty. There's a whole bunch of black stuff that seems to come off of it. In fact, I could probably pop that. Don't know if you can see it all that well. It's kind of cleaned off a little bit, but there's black stuff just all over my drive roller on there from when I was doing this before I had that wire cleaner on it. So anyway, make sure, it's not necessary, but I think it helps a lot. So if you're having some issues, maybe consider grabbing one of those little wire cleaner lubricant deals, and it should help out. Now, next point to be made. My drive roller, come on, focus. Maybe. So, my drive roller down there is what's called a serrated. There goes the focus. As you can see, it's got a whole bunch of little notches in it. Now, I've got two sizes of grooves on there. I'm using the smaller one for this wire, which fits a little better. My other drive roller, hopefully I can get it. This is called a V or U groove. And you can see that it doesn't have any of the serrations in it. So, the non-serrated V groove roller, that is meant for solid wire. That's meant for your regular MIG wire. If you're running flux core, try and get one of these grooved rollers, because that will help the roller grab the wire and push it through and make it so that you don't have to tighten down your tension so much that you crush the wire. So, let me click my tensioner back in here. As you can see, maybe, come on, focus. Right now, I don't have a lot of tension on this. You can see a 3, a 4, and a 5, 5 being the max, and I think the minimum is a 2 on this one. I'm at about 2.5. So I'm using very, very little tension on that wire, and the reason being I don't want to crush that wire. So flux core has a core of flux that has steel wrapped around it. So it's not a solid wire. So if you put too much tension down, you can actually crush and flatten that wire. And if you crush and flatten that wire, there's a good chance that it will not feed properly through your gun. So make sure that you don't put too much tension on it. Okay, I'm going to go ahead and flip on the machine. Actually, no, I'm not. I'm going to go ahead and show you my technique for this, and then we'll go ahead and flip on the machine, go over the settings, and hopefully run a bead. Okay, so technique for flux core. There's kind of a rule of thumb out there that says that if you have a flux, then you drag it. No flux, and you push it. And what that is referring to is how much angle you either drag the wire with or you push the wire with. So, where this is a self-shielding flux core process, we are going to be dragging it. So, what you kind of want to do, if you're running it just like on a flat, you want to get that about 90 degrees to your plate-ish, somewhere around there, and then add about that much angle. So it's not much. If you're straight up and down, you just want to just a little bit. And then you just drag it along. Pull the trigger and just hold that trigger and drag it along. Now, I will be the first one to admit, I don't always follow this rule. This wire in particular has been running both ways. I can either drag it or I can push it. I've had mixed results with this wire, to be honest. Now, let's also talk, so that's if you're on a flat plate, you're just going to be mostly straight up and down and give yourself a drag angle and just drag it along. If you're working in, say, a fillet like this, you want to try and be directing straight into that joint. So, about like that. It's going to feel kind of like a 45 coming straight out of that joint. So, you'll be at about a 45. It's a little subjective. You're going to have to make adjustments when you get welding and you're under the hood. Main point being, make sure that your puddle is on both the bottom and the top plate of your fillet as you're going. So, that's straight on, and then just give it a little bit of an angle so that you can drag it along. Now again, it's a little dependent on what wire you have. This wire, I've got it to work both forwards and backwards. So in both a push angle and a drag angle. Now what I will say about this wire, as you can see from all of the beads that I've run on here, and this is part of why it's taken me so long to get another video out, this wire acts a little bit strange. Now what I think is going on is this wire, so when you get welding, the wire heats up and then expands. And I think it's getting a little tight in the nozzle. So I just recently, this is advertised as an 030 wire, 0.030. It runs on settings for 0.035. And I've got a 0.040 contact tip on here. So the reason behind the oversized contact tip is as that wire gets hot and starts expanding, hopefully it won't lodge itself into the contact tip and not feed correctly. So that's that. But anyway, you're just going to get in there, give yourself a little bit of angle. You'll notice that I like to prop up on something. So my hands are propped up on something to help me be stable, as opposed to just floating where I can, wobble around and all that. I try to, get on something to help me get stable. That might help you if you're having difficulties. The other thing, so this nozzle gel that I was talking about, again, I'm using it. There's going to be some differing opinions on whether you should use this stuff or not. I'm going to, because I've had a lot of buildup end up right on the end of my contact tip while I've been welding, and that has caused some feed issues. So I'm going to be using this stuff to keep that buildup off and keep this hopefully feeding correctly. And all you do is just, you can see I got a whole bunch of holes in there. Just dip it in, get it on, call it good. And voila, you can see a little bit on there. That's just to help keep the spatter and a whole bunch of the other stuff from accumulating and causing feed problems for me. So let me go ahead, throw on my helmet and my gloves. We'll get the lens on the camera and we'll try and run a bead here after I show you my settings on the machine. Okay, so the machine's on. If you look over here on my process selection, you can see that I have it set to flux cord. Remember, flux cord is a gas-less process. There's no gas used in flux cord. Again, flux cord self-shielding. There is a gas that's used when you're flux cord dual shield. So again, make sure you know what wire you have. And maybe at the end of this video, I'll go over some of that specification process so that you know what to look for. But anyway, so as you can see here, these are all my settings. Right now I'm running 215 wire feed and 21.5 on the voltage. Now, wire feed is directly related to your amps. That's why it says WFS/amps. So this is my amperage as well as my speed. They're directly related. Now, whatever machine you have, you should have a chart that tells you roughly about what your voltage and amperage should be for various materials. On the Everlast Lightning here, I have this synergic setting. So if I turn that on, now it brings up all of my settings, okay? So, 0.035, again, this wire is supposed to be a 0.030, but it runs better as a 0.35 or on the settings. So you can see that I got 20.9 volts and 283 wire feed speed for roughly, that's a little bigger than 1/8 inch. Let's see, this button, 360, okay. Yeah, that's closer to the material. So that's what this suggests. Now, when I've run it at this, it's been haphazardous, to say the least. It kind of spits and sputters, which indicates that I've got too much wire feed speed, but I turn it down and it doesn't fix the problem. So there's a good possibility that I just have a wire that's not cooperating with this machine. That is always a possibility with flux core, and you got to be careful what flux core wires you get out there, because some of them don't jive well. But anyway, so if I was looking for a ballpark on where to set this, I'd start here. I'd probably go through my material selection until I found something that seemed to work. This was the closest that I got, and so I took these numbers, put them back into my manual setting, and adjusted from there. Now, I could probably do with a little less voltage. We're going to try that. So we're going to try these settings and see what we get. So let me get the camera on the tripod and get the dark lens on it, and we'll see if we can get a halfway decent bead. Alrighty, there's the bead that we just ran. I haven't chipped it yet. I just kind of wanted to show you, but you can see there's a slag over it. Now, what we just did there, that is ideally kind of what you're looking for when you're running this. You probably noticed a couple of little hiccups in there, and you can kind of see I've got a bit of a gap there that I didn't close up all the way. So those hiccups were me getting a little too deep into the gap and just shooting the wire through without fully welding it. So, you know, I kind of whipped it back to the puddle where it was still hot just so that it could get reconnected again. I was probably traveling just a little bit fast. I did slow down my travel and let that fill in a little bit more. But let me go ahead and chip it. And remember how that sounded. It sounded very clean and it sounded very consistent. That's a big thing that I look for when I'm welding this, is does it sound clean and consistent like what we just got there. So that's usually your first indicator whether you've gotten your settings right or not, is how clean does it sound. But anyway, let me go ahead and throw on my safety glasses, grab my chip and hammer and a brush, and I'm going to clean that up so that we can get a look at the bead underneath it. Alrighty. I'm attempting to add another light source so that you can see this better, but it's kind of working. So there's the weld bead that we made. Couple of, characteristics that I want you to kind of notice on here. The beginning of the bead, back over there. In fact, do I have a, here we go. So at the start of the bead, kind of from here to about here-ish, you'll notice that it's built up a little bit more in the center, and that kind of has to do with a cold lap situation. And this is also where I was trying to, blow through the material because of that gap that I'd left myself and where I was whipping. So there's a little bit of that going on right here, but you can see that the bottom toe and the top toe is all fully fused in. That's what you want. That's what you're looking for, is you want those toes fused in, just like any other weld process. So that's what we got there. I did just remember there's a setting that I didn't talk about that I probably better mention. So let me turn the welder back on. Everlast, flux core, no gas. Okay, so the setting that I forgot to mention that I should mention is this one, inductance. So if you've seen my multi-process versus single process machine, I touched on this a little bit before. So this is inductance. It might be called arc control. There's a couple of different names for it, but this basically controls how fluid your puddle is. So if you're getting a really heavy crowned center, but everything feels like it's running right, you might need to adjust this. Now, if you have a single process machine, or you got a machine that's supposed to just deal with flux core and nothing else, there's a good chance you might not have this setting. Some manufacturers will not give you this setting for their machines, and they just set it at the factory. But anyway, so I wanted to point that out. Flux wires, usually if you have the setting, if you have it, they usually take a bit of a higher setting, or a more softer setting. I know Lincoln kind of classifies it as crisp and soft. And what that means is the soft is a more fluid puddle, if that makes sense. Hopefully it does. So it should lay in a little bit better as opposed to being really high in the crown, in the center. So if it feels like it's running right, but it's not quite looking right, check that setting if you have it. If you don't have it, well, I hope your manufacturer knows what they're doing. Before I round this video off, let's go inside, take a seat, and I want to talk about the wire, the specific wire that I got, and some of the classifications that you need to watch out for when you're selecting a wire. So let's go talk about that. Okay, so here we are back inside. As you can see here, I have a KT Industries mild steel gasless flux core box in front of me. This is the wire that I got out in my machine. Again, still having mixed feelings about this wire. I feel like it should be running better than it is, but it does run pretty good. So, I don't know. It's what I got, it's what we'll show you. So, as you can see down here, it says mild steel gasless flux core. And then you will see this number. Now, the main part of this number is the first half here, this half right here. This little classification here is KT Industries' way of saying gasless. So this is meant to be a non-shielded wire. No shielding gas required. So let's break some of this down. So E71T. Obviously you can kind of read this, but you know, I'll go over it. It looks a lot like well, I want to say that it looks a lot like a stick welding electrode classification. So those of you who have seen my beginning videos of stick welding on the channel, if you haven't, please go check them out. I went over the classification setup for stick. This is similar, but not quite. So on stick welding, so you had the E, which still stands for electrode. Now on stick welding, you would have a 7-0. That 7-0 was then times by 1,000 to get your tensile strength. On flux core wires, at least most of them, this is not always true, but for the grand majority of them, you'll only have one number. And this number is times by 10,000 instead of 1,000. So that is your 70,000 pounds per square inch of tensile strength. So they've consolidated that down into one number. And then they have a second number here, which is a position number, which Google will give you a couple of different things that you can read. Usually you'll see either a 0 or a 1. 0 is a flat or horizontal position. 1 is an all position. So I have a 71. So I should be able to weld this flat, horizontal, uphill, downhill, and overhead, everywhere that I need to weld it. And then the T stands for tubular. So it is a tubular wire, meaning that it has a core of flux. So that's the big thing that you're looking for right there. Look for that T, because that's going to tell you that it has a flux in it. It is a tubular wire with a flux running down the middle. Now, remember how I said there are self-shielding wires and there are dual shielding wires. So again, self-shielding means that it's gasless. You don't need a gas to run it. If it's a dual shield, you need a shielding gas. So let's take a look at these other numbers here. So we still got the E71T from the beginning, okay? The same thing right here. Now this is where it can get a little muddled, and I really wish that manufacturers would adopt a more standardized practice, but that doesn't always happen, because like on this one it says GS, which is supposed to stand for gasless. If you see, there's usually a dash number and then there'll be another number right here. The number here kind of refers to some structural code deal, if I read that correctly, and then you'll see either a C or an M. You're looking for this C or M. If you see a C, then you need a 100% CO2 shielding gas. The M is supposed to stand for an argon CO2 mix gas. Now, when I was looking at all of this, a lot of wires seem to be interchangeable on their gases. Just pay attention to it. If you see a C, that means that it wants a 100% CO2 shielding gas. And if you see an M, that means that it's looking for an argon CO2 mix gas. If you're not sure, contact the manufacturer. I can't stress this enough. Contact the manufacturer if you are just completely unsure of what you need to do. Because again, you'll have E71T dash, and then some sort of number, and then a C/M or a C or M. So that's kind of how they do the classifications for these wires. Pay attention. If you just see E71T and it could have a dash something something, but if you don't see the C or the M, you should, emphasis on the should have a wire that does not require shielding gas. So pay attention to stuff like that, and hopefully you will be set to weld some flux core. So anyway, all right, that's going to do it for this video. I hope you guys learned something, and we will see you guys in the next one.